finding what? What are we finding? Okay, vertical asymptote, so this is us right now, and it says this. If a rational function, which is a fractional function, is in what form? Simplest form. Now, simplest form means it's already been what? Factored slash canceled. So you cancel out what you can, is what I'm saying. Factor it, cancel it. Then, if it's in simplest form, you've got a numerator, you've got a denominator. Then the vertical asymptotes occur at the what? Zeros of the denominator. Okay, so this one. Is this factored on top?
Yes.
Factored on the bottom?
Yes.
So it's in simplest form. All you have to do to tell me the vertical asymptote is just tell me the zero in the denominator. So set your denominator equal to 0. That's all you have to do. X minus 3. When is it 0? When x equals 3. So your vertical asymptote to this problem is right here. X equals 3. So if you were graphing this, the first thing once you know it, you might as well come over and graph it. Okay? And maybe just label it. Okay? Okay, so that's number 1. But number 2 is a little more difficult. Try 2 on your own. And remember, it needs to be what? In simplest form. So do this, then do what I just did. So top could not be factored, bottom could be factored. What happens with the factors?
Cancel.
Okay, this number is the same as this number. It's like reducing. It's the same number, so it's 1 over 1. But what's left is?
1 over x.
1 over x plus 4. Okay?
X minus. Oh, wait.
No, I think x plus 4.
Yeah, you're right.
Okay? Well, what's the vertical asymptote? The vertical asymptote is when you set the denominator equal to what? 0. Well, the denominator is x plus 4. Whoops. X plus 4 equals 0. So the answer is?
-4.
There you go. This becomes the vertical asymptote. Okay? All good? Oh, you're not ruining the calculator, are you?
No.
No, good.
Well, you don't need it
Then
right
leave
now,
it.
so what do you have to do?
That's, you don't need it right now. Okay? All right, next. Give me the domain. Give me the domain of your function. This is the first question I ask you on every problem. What's the domain of your function? Okay. Now, the domain, if I were you, I'm just going to write you a quick note. I would factor it first, then give the domain. So what's the domain after you factor? Okay. I don't think you can factor the top. X minus 2 is already a linear factor. Stop. Don't do anything. But the bottom is quadratic. Can you factor it?
Yes.
X what? X minus 2 times x plus 2. Good. Okay, that was pretty easy. But now the question becomes, what's the domain?
All reals except -2.
All reals except x can't be what?
-2.
Okay. But x can be 2?
Yeah.
X, the
Why?
negative
'Cause they
2
cancel
cancel
out.
out.
Well, hang on. When it comes to domain, this is not a vertical asymptote. I'm not talking vertical
All
asymptote.
of them apply then.
Well, then 2 or -2.
Yeah, it's positive and negative. Okay. So the question becomes, what am I looking for? Am I looking for a domain? If I'm looking for a domain, just factor. Look at the denominator and go, oh, x can't be -2, x can't be +2. There. But hang on. What if I was asking you for what? Vertical asymptote. What would it be now? Here, then you cancel out this with this and get what? 1 over this, right? Which would lead you to believe it can't be, or the vertical asymptote is,
You're wrong.
x equals,
-2.
oh, yep, because these cancel. Sorry. Plus, which would lead you to believe it's this, right? Good? Okay, sorry. So there's a little difference there. When you do domain, you just factor and you just look. Hold out, tell me what it can't be. When you do vertical asymptote, factor it, cancel it, then look, and tell me what the asymptote is. Okay? Okay. Now we go into horizontal. Now horizontal would be boom, right here. Okay. If your function f is a rational function of the form this. Now when I say n of x, d of x, you know it's numerator over denominator, but these are polynomials. And when you look at the polynomial, all you care about is this. Just the highest degree of x and the coefficient in front of it. Okay, so there's a couple things you care about. The rest of it, whatever follows, you don't care about. Okay? All right. It says where d, n of x and d of x have no common factors. So that means you have to do what first? You have to simplify first to get those horizontals.
Yeah.
Here it comes. Number 1, if this is true, if n is less than m, where do you see n? Where do you see m? Tell me those. What's the word?
there's
The
the
exponent.
exponent.
Okay, guys. If you look here, there's n. If you look here, there's m. Those are the exponents, but the exponents, they just tell you one thing. They tell you what degree you're looking at. So this to me says, if the degree of the numerator is less than the degree of what?
The denominator.
The denominator, yeah. Okay,
Keep up.
then it says the graph has a horizontal asymptote with the equation what?
Y = 0.
Perfect. That's it. It's a given. There's really nothing to think about. You don't have to do any work. So what I'm trying to tell you is this. If you ever see this, x to the second divided by 3x to the first. And I think I did that wrong. Let me try that again. Sorry. Okay. I want n less. So this is 2, and this happened to be 3.
3.
Would you agree the degree on top is less than the degree on the bottom? Okay, so this tells me horizontal asymptote must be what?
0.
Y = 0. So there's really no work to do. You just need to know these rules. Okay? The next one says, number 2, if the degree of the numerator is equal to the degree of the denominator, the graph has a horizontal asymptote with the equation y equals a over b. Where do you find a and b?
Right there.
What are they called?
Coefficients.
Leading coefficients. The leading coefficients, okay? So if I make one up for you like this, if I give you x to the 4th, x to the 4th, and I put a 8 here and I put a 2 here. The degrees are equal, so you just look at the leading coefficients and you say the horizontal asymptote is y equals 8 over 2, right? Better yet, y equals what?
4.
4. Okay? And you have to know the rules. You just have to. Okay, this one's nice. You like this one because if the degree of the numerator is bigger than the degree of the denominator, the graph has what?
None.
None. It doesn't have any horizontal. Okay, so then an example would be x to the 4th happens to be on top of x cubed. You'd say the degree of the numerator higher than the degree of the denominator, so you'd say no
So you're only gonna have a value.
horizontal asymptote.
You're only gonna have a horizontal asymptote when they're even. Like
If
an actual
you,
number that's not
you
zero.
will have horizontal if the degree on top is smaller than the degree on the bottom.
No, but
It's-
it'll be zero though. So
it's
like,
always
it's only an actual number if they're equal.
if they're equal like this,
Yeah.
then you look at the coefficients. Sorry, Will, what do you see?
Never mind.
Say it
I
again.
know what you're saying, love.
Never mind.
Say it again.
I've got you.
It's fine. I got it.
You got it?
Yeah.
Hey, if this was 18, what's the answer?
9.
Y equals 9. Okay? That's all it is, right?
Oh.
All right. Next, find any vertical and or horizontal asymptotes to this problem. Go. X minus 4 over what?
X plus 3, X minus.
X plus 3, X minus 3. Is there any cancellation going on? No. So is it simplified?
Yeah.
Yeah, it's simplified. All right, ready? Let's go after vertical first. If you want vertical, here's vertical. All you have to do is set your denominator equal to what? 0. So here's your denominator. When is this 0? Negative 3.
Positive.
Okay, so x equals plus or minus 3. That's it. There's 2 of them. Boom, boom. Okay? Horizontal. This is all you got to do. Just, well, there was nothing canceling out. So really, you got to understand that this down here is really what? It's an x squared polynomial. This on top is x to the first. If the degree on top, the numerator, is smaller than the degree on the bottom, it's automatic what?
Y equals 0.
Y equals 0. There it is. Now, I know I didn't say this. Would you just please make a sketch of that? Okay, here we go. 1, 2, 3. 1, 2, 3. Vertical. Vertical. And horizontal is where? At 0. Okay, so this is how the whole picture gets started like this. Then you're wondering, well, where do all these kind of like parabolas go? Because they're kind of weird looking parabolas. Well, then you have to worry about this. On Monday, when you do a graph, you have to worry about these x's from negative infinity all the way up to what? Negative 3. And you would do what to figure out if you're up here or you're down here? What would you do?
Plug
Plug in 0.
Plug in a number. Well, from negative 3 to negative infinity, you'd plug in probably,
-4.
I can't plug in negative,
Negative 3.1.
negative 4. Okay, so if you plugged in negative 4, you would either get positive or you'd get negative. Let's pretend you're going to get negative. Well, there's no reason to try anymore. Because you know you're where? Top or bottom.
Bottom.
So you know as you get closer to negative 3, this thing is not going to go this way. It can't penetrate. So it's got to go this way, and down. As you go this way on the x-axis, it's just going to ride out like this. Then the next group of x values you're worried about are from negative 3 to what? Right here. Pick a number. What would be a good number?
4.
0.
Hunter 4 is out here.
0.
I try 0. If you try 0, you might get this answer right here. And if you get that answer, you have to realize as you start putting in 1 and 2, it's going to go this way, but it can't go down because this is the horizontal. It can only go this way, and back up. And the same here. It cannot go through these asymptotes. Okay? And then, of course, the last region would be from 3 to what?
Positive infinity.
And you just pick a number. And of course, I stay close to 3. I'd probably pick 4. And I'd get maybe, let's just pretend I get this. And it would have to do something like that. So that's why they get so wicked looking. They get really crazy looking and they're not easy to graph, okay? I
Oh,
know
yeah,
I did not tell you to do that, but I just wanted to show you.
Could you get a positive value if you plugged in positive 4?
You could.
And-
I was
and
making
then-
that up.
And then, like, still have it on the bottom side if it's negative 4?
Oh, do you mean
It could be either way.
this? And then over here, you want it up here? Or what?
No, on the left side, it's still down. Like, it's still underneath.
They could
it,
be
but on the
opposite.
right side, it's above.
They could be opposite.
They could be here, they could be here, they could be,
Okay.
you know what I'm saying?
I was,
The only
I was
thing I'm
wondering
trying to
if
tell
they'd
you
be on
is-
the same side.
Here's the
above
thing,
and
you can't do this. You can't have one here and one here.
below. Right.
But that would be a function.
I know, that's why. Okay. Zeros. Let's go get the zeros.
Let's go get.
What are the zeros?
Negative. Wait.
No, I'm not asking you to answer. Just tell me what a zero is to you.
It's where it
It's a
crosses.
factor. It comes from a factor. That's not what it
It's
is.
an asymptote.
It's an asymptote, no?
It's a solution.
Where it goes.
It is a solution.
Where?
Do that.
Where what?
Where it goes.
Where it goes through the x-axis, otherwise known as the
Intercept.
x-intercept. Okay, so a zero is an x-intercept. If that's all it is, then that means you're looking for this, but you know what? You know y is zero, don't you? Okay, so when somebody tells you to go get the zeros, they're telling you, go get the x-intercepts. If that's true, why can't I just do this? Right? Good? That's all you gotta do, right? To get zeros? Let y be zero. Okay. Can I turn you loose? Can you go do it? Solve it. But what are you doing? You're factoring? All right, I guess I could factor. You want me to just, so when you say factor, you're just saying change the look. Okay, I'll change the look. Here we go. X what?
Minus 3 plus 1.
Okay. X what?
Minus 2 plus.
Or minus 2 plus
Oh, 2 plus 2.
Go ahead.
I'm not sure if that solved it. I think you just changed the look is all you did.
Makes it easier.
It makes it easier. Okay. So what do I do?
The numerator is
Figure out when each of them.
Figure out what?
Figure out when each of them goes there.
Each factor.
Yeah.
So this one, this one, this one, this one.
Yeah.
That would get you too many zeros and they're not all right. Too many. Yep.
If the numerator is 0.
Well, you read your sheet.
But he's right.
Well,
He just uses his resources.
Okay, guys, listen.
Numerators
If I was told to solve that, you're supposed to be thinking like this. I don't like the look of this, so I'll probably try to get rid of something. And most people don't like denominators because that's fractions. So what most people do is they say, I want to get rid of this part of the fraction, x minus 2. Why can't I go like this? That would just cross that out, right? If I want to get rid of this one, it's x plus 2, right? That goes away. Now you have just that. But on the other side, you'd have to multiply by the same two denominators. But the cool thing is when you do this, you get what?
0.
Still 0. So now you have this.
So you literally just can cancel.
Yeah, so literally just
Throw
discount.
out the denominator.
Okay. But you gotta know why you just throw it out.
Well, no.
I showed you why.
I don't want it.
But this is what Davidson did. He read his sheet, didn't you?
A little bit of problem solving, a little bit.
Okay.
That was on that.
But here's the deal, guys. When it comes to finding zeros with rational expressions like I just did, it is just find the zeros of what? The numerator. Okay, so when you want zeros, just set your numerator equal to what?
0.
That's all you gotta do. It's easy. So tell me, what are your zeros?
3 and
3,
negative 1.
0, right?
Yeah. Negative 1, 0.
Yeah. Okay. Now, how does that help you? Well, your graph has x-intercepts of 3, 3, 0, and negative 1, 0. So now you have 2 points, 2 free points. Free. You just put a point and a point, you got it. So, how do you get zeros? You just say, when is my numerator what?
Zero.
0. That's all it is. Okay. Here's a little quick note just so you know this. A graph can have many, many vertical asymptotes. So just maybe do this. I want you to know that it can have many. I'll call this one negative 5. I'll call this one 2. I'll call this one 6. But could there be more? Oh yeah. But no more than what?
One.
One horizontal. Does that mean there, okay, so there can't be 2, but can there be no horizontals? Yeah, we already talked about it, so yes, there could. We'll go like this. Okay, and we'll call this y equals negative 3. Okay, so this is how wicked stuff can look on you. Now, again, all you care about when you graph on Monday is from negative infinity to what number?
Negative 5.
Negative 5. And what you do is you plug a number in again, like negative 7, and wherever the answer is, let's say it's down here, you kind of know it goes like this, and it goes like this. I'm sorry, that's kind of bad, but whatever. You know what I'm saying? And then, of course, now you got to worry about from negative 5 to what? 2. And if you knew a couple things, like if you knew the x-intercept was right here, if you knew it was here, and you just wanted one more point, maybe try a 0. Oh, 0 is, let's say 0 is here. So you kind of know it goes maybe like that, you know, so you would know a couple things. And this is what you're doing on Monday, okay?
There'd be a horizontal and a slant.
There can be slants and horizontals, yeah. Or what did you say?
Like at the same time.
Oh, yeah, there can be, but it won't get that messed up. Okay. Oh, I think we're ready. We're finally going to do it. We're going to graph it.
Okay, we should be done.
Sketch in the graph.
Should just be done.
We want to be done? Will's done, guys. Should we quit?
Yes.
Yeah.
So however Will feels, that's how we work.
Yes.
Pretty much.
Will
I'm
speaks
opposite.
for the people.
I'm opposite of Will. If Will says stop, I say
Alright, let's go.
You know what that means?
you already talked. You can't talk again. All right, here we go. Hey, look at your sheet, please. I got 9 steps. We're gonna do them all. Ready? What's the first step? First step is what?
First step. Factor.
Okay, it says factor it, then what?
Rewrite the determinant domain.
Okay, let's get the domain. Here we go. I'll come down here. This is f of x. Guys, you can get ahead of me if you think you know what you're doing. Go ahead. Every problem starts out by saying, what's the domain? And you'll say, I'll factor it. And then I'll tell you the domain. And the domain, to me, is everything gets an answer, except when it's a fraction like this, you can't have 0 on the bottom.
Negative 4 and 2.
Okay, comma. Don't let x be negative 4. Don't let x be positive 2.
Or 0.
What?
Like you have to put 0.
Well, you can have 0 works. If you put 0 in, you get 4. 0 here gives you negative 2, right? Yeah, you'd get an answer. If you put a 0 in, you're going to get an answer. But if you put in 4, negative 4, it doesn't work. You put in 2, it doesn't work. Okay? You okay, guys? Number 2 says what? Okay. Simplify the fraction by eliminating common factors, and then make a note off to the side what you cancel out. Okay. All right, here we go. Okay, so you canceled what out, guys? X minus 2 with x minus 2. So now your new function is f of x equals x over
2x plus 4.
Okay, gotcha. There it is. Okay. Now, it did say, just make a note to yourself, what did you cancel out? X minus 2 with a what? X minus 2. Okay, just a quick note. We will come back to your note later. Okay? Number 3. Okay? Now, by the way, this is the function you're graphing right here. You're not graphing the first one, you're graphing this one. I don't know what 3 says.
Find 0.
Okay, if you guys remember, the zeros were simply, whoa, I did that wrong. The zeros were simply what?
The numerator.
When the numerator happens to be 0. So just set your numerator equal to 0. Well, which one's your numerator? X. My 0 is 0. But guys, zeros are just what? They're x-intercepts. So why don't you write it as an x-intercept? Zeros are just x-intercepts. Hey, that's a free point on your graph. That's a free point. 0, 0 is on your graph. Okay? Next, 4.
You gotta pay for them usually.
What's 4? Okay, vertical. Vertical asymptotes. Okay, just do what? Set what equals 0? Denominator equal to 0. Oh, is that all it is? Well then, what's in your denominator? A 2, which will never be 0 by the way, and an x plus 4. So when is x plus 4 0?
Negative.
When x equals negative 4. There it is. Guys, we'll come back and we'll graph these later. Let's just get the information. All right, 5. What's 5?
Find the horizontal or slant asymptote.
Okay, so here's the deal. Horizontal, you just have to look at the degree on top over the degree on the bottom. So here's the degree on top. It's just x to the first over, is it 2 times x what? Plus 4? Okay. If I multiplied this out, would this be an x squared function down here? No, it would just be what? X to the first over 2x plus 8, right?
Yeah.
Are your degrees even?
Yes.
Yeah. So now it becomes
X.
the leading coefficients,
1 over 2.
1 over 2. So your horizontal asymptote is y equals 1 over 2. Better yet, 1/2. You okay? Okay. Keep going. 6. 6.
Determine at what point, if any, the graph crosses the horizontal slant.
Okay, look at this. This is a horizontal. I never told you this. Most of the time, your graph will never cross. But it can. It can cross the horizontal. It can also cross the slant. But it can never cross the vertical. Did you hear that? It will never cross the vertical, but it could cross the slant, and it could cross horizontal, and it could cross the slant. So, when will it cross? If you want to know if it crosses, take your function, set it equal to what? Your horizontal. Now, what was your horizontal? 1/2. Okay. Quit flying your plane. Put it down. Okay. How do you solve it? Multiply what? By?
Both sides, but
Okay, what do you want me to multiply by?
2.
2?
2.
Okay.
X.
That's it, just 2?
No.
I don't like that. That's the more complicated one, isn't it? Why wouldn't you just multiply by the more complicated one? Okay. That would just cancel that, right?
Cancel that.
You'd end up with x over here. On this side, you'd multiply by that. But that is really 2x what? Plus 8. Times what? 1/2. What's half of 2x?
Wouldn't the 1/2 and 2 just
X.
cancel out?
What's half
Yeah.
of 8?
4.
4. Okay.
Yeah.
You got x's on both sides. Move the x's over. How? Minus x. And what happens here? 4 equals
Doesn't work.
0. which is false. And if you remember the question was, does it cross the horizontal asymptote?
No.
No. Okay. So this is no. It does not cross the horizontal asymptote. So that's information you need to know. Oh, day 2. Sorry. I think I'm done. You just got to graph it now, right?
Yep.
Okay. Let's go graph it. Somebody tell me the vertical asymptote. No, that was the horizontal. Y equals 1/2, right?
Nope.
Wasn't it y equals 1/2? That
Oh,
was
yeah, it
horizontal. What's vertical?
-4 and 2. Or just negative.
I think it's just -4, isn't it?
Yep.
Okay. Okay. I gotta tell you something. I think the bell's gonna ring, so I'm gonna say this to you. You don't have to graph today. So what I'm doing is way too much. Today you'll be asked simple questions in your book. When you get back here Monday, we got a couple more slides to do. I'll give you 8 problems on Monday. Okay? Your book assignment is not hard. Just get to it. It's Friday. Do it sometime this afternoon, and then you can chill out over the weekend and have fun. Then come back on.
All G, let's go. Yeah, next. Yeah, wait on this.
Shoot. I'm all Wait. Oh, God. Yes. I'm about to, because apparently you didn't even imagine anything. I want to die. That's him.
I don't know if I could.
You see the
Right.
I'm not like a dog eating.
It's tired of me saying, you know what I had?
Oh, dude, your service.
Hot chocolate.
Oh yeah, yeah.
Oh, yeah.
Where do you guys move?
They're not a 5-star.
Back up.
I'm just saying.
Look at the top bar.
All that work on
So why would
No, I
Oh,
Bill, yeah, Bill. They're not gonna get the one, because I gotta finish it.
No. I'm just like,
Well, they
I'll
can't.
put it on. When something happens, and it does.
I did last night. Yeah, no. So I did it. Guess what? That's what it is. You got the answer. You know me wrong.
Arena defense. What?
Yep.
I don't know.
Hey, no.
There's a 2-3P and I need it. Stagger. It doesn't say words. Yeah, so I just feel like I had really bad. I was on a bus. Sitting on a bus. Oh, I had to A for one of them too. Which one is it?
It's just how hard you work. That's what it comes down to.
So I don't even like
If you're there to lose.
what if I don't answer?
Well, then you know what?
Wait.
But it's just a waste of your time. But you can do it. Most likely they'll.
Why did I need to get like? I got so many good grades. I was like,
I got part A.
They'll tell you what.
You said you
So
were
I'm
first,
gonna this all.
I can't. Yeah, and you
Okay,
see, I would.
I'm talking to everyone. I know, I'm just saying.
I told you,
Three. 2, 1, 2, 5, that's today.
oh yeah, you did. Well, what's my feeling about it?
Well, I had like one.
I can always do the
Yeah. But now it's the only problem.
You gave me lunch ago.
Now you're gonna get that. So. You just go like.
Oh, and you said.
Okay. Give me a second, Greg, 1 second. Alright. Alright, so here's what I have. I got a couple people that gave me some late work. That's good, by the way. I need your work. But here's the deal, guys. The later and later it gets, the fewer the points you get too. So it's all good you gave it to me, but please, sooner the better. I'm going to tell you this. You had the answers to the worksheet yesterday. You had it. I told you, take a picture. Go home, look at it. Ask yourself, what do you get? What don't you get? So you should have given in here after school last night saying, help me, help me. So I'm thinking today you should be ready just to give it to me, the worksheet, right here, and then any makeup can go there. Makeup here, worksheet here. I don't want to talk about it because I was talking to you all period yesterday about it. I just want to go with the slides. So let's go. I'll give you 1 minute to put it all up there.
Alright, guys.